Okay, everyone, let's start immediately and talk about the nomenclature of compounds. Let's start with naming ionic compounds containing representative group elements. Now, what is the meaning of representative? This means that you have A group elements, like 1A, 2A, and etc. So, what is the rule for naming ionic compounds? The rule is first you tell the name of metal plus you tell the name of nonmetal and you add "ite" in the end of naming. So most of the compounds ending with "ite" means they have two elements in their formulas, like sodium chloride. You have one sodium and one chloride atom. But sometimes there are some polyatomic ions ending also with "ite" here. So be careful, sometimes we can have exceptions in naming these ionic compounds. Okay, let me give some example. As we have told already, you have this one sodium and one chloride, so you just name it as sodium chloride. Now be careful, you do not use the prefixes like mono, di, tetra, etc. When you're naming ionic compounds, you only tell the name of the metal as sodium here, then the name of the nonmetal as here, and you add "ite" at the end of the naming. Another example, let's say that you have one aluminium and three fluoride, they combine to form that ionic compound. So this is called as aluminium fluoride. What else? If I have two potassium and one oxygen, this is a compound containing one A group element, which is alkali metal, and this is 6A, the oxygen. So when you name it as potassium oxide. Okay, what do we have more? Another example. Let's say that you have this 3 sodium and 1 nitrogen atom. You can name it as sodium nitride. So let me give you another example, in this case containing hydrogen atom as the nonmetal and as the anion. So this example can be important. For example, this one. You have magnesium here and hydrogen here. You know that hydrogen is mostly found in covalent compounds, covalent molecules. So when hydrogen is combined with a metal, it gets the oxidation number of -1. So this is an ionic compound, and you read it as magnesium hydride. So this is all we can say about the naming ionic compounds containing the A group elements. Let's continue. Now, if you have ionic compound containing polyatomic ions, now just sorry to tell you that you have to memorize all the names of these polyatomic ions, not their names, but also their charges also. For example, when I say sulfate, you should be able to tell that this is 1 sulfur, 4 oxygen with a charge of 2- here. Or when I say nitrate, in this case, you can tell it as 1 nitrogen, 3 oxygen with a sign of -1. So you have the list, you can find the list anywhere you like, in internet, in books, etc. And also they have been given for you in class, so you're going to use these names and the charges especially. So let's start with the examples. For example, if I say this one, you read it as potassium sulfate. Now just be careful, I do not say dipotassium monosulfate. Again, you do not use those prefixes. So the numbers of the anions and cations are not important. You just tell the name of the metal, tell the name of this polyatomic ion. So it's all done. Okay, what else? This is sodium nitrate. Okay, another example. You have this one, and let me give you another one just really similar as the previous one and this one. So the first one is, now remember calcium is in the group of 2A, which means that calcium has the oxidation number of 2+, where this polyatomic ion has the oxidation number of 2-. So if this polyatomic ion containing has the oxidation number of 2-, this means that you have the manganate ion. So you read the name as calcium manganate. So what else? The second one. Here you have the calcium as the charge of 2+, and you have again a kind of manganate, but which one? It has a charge of -1. This means that this is permanganate ion. So you read it as calcium permanganate. Another one. Let me give you the anion of inorganic acids. This is the acetate ion. So you read it as sodium acetate. So this is the kind of exception. In most of the times, you put the cation in the beginning of the compound. In those organic salts, you just put it at the end. But if you just put it in the beginning again, it doesn't matter. It is just a kind of exception. Okay, another one. If I have this one, and remember the name of this Rb symbol. This is rubidium. Now, what about this NO2 -1? Now, this is in the group of 1A, so it has a charge of +1. So this is -1. So remember, this was nitrate, and with the number of oxygen atom 3 here. So if you have with the number of oxygen 2 here, this means that this is going to be nitrite, just like this. So when you just memorize some kind of polyatomic ion containing a specific amount of oxygen, and if it ends with the nitrate, for example, so if you have one less oxygen than this one, it is going to end with the nitrite. So this is valid for example, sulfate and sulfite, and also phosphate and phosphite. So list of these polyatomic ions are really important. Okay, now comes the best part, the transition metals. Now, transition metals, as you know, they're found in the middle of the periodic table, and they can have different positive oxidation numbers. But you have some transition metals having constant oxidation numbers. So when you have these elements, we're going to just behave them differently. Okay, what are rules for naming these transition metals, any compounds containing transition metals? Now you have the name of metal, then in parentheses you're going to add that oxidation number of this transition metal, plus you have the non-metal, again plus art. Or what can be the other choice? It can be ended with a polyatomic ion. So only difference from the previous one is the name of the metal, also mentioning about its oxidation number. So what are the most transition metals that we are going to deal with? They are, for example, copper, manganese, cobalt, mercury. What else do we have? We have nickel, iron. So these are all their B group elements, and we have some more metals. In fact, they are not called transition metals, but they are called post-transition metals. For example, this is lead and tin, and they are found in the group of 4A. They are not transition metals, but also their oxidation numbers are written in the middle of the naming. They are called as the post-transition metals. So when you see these, probably see these metals you're going to just realize that I should just write that oxidation number in the middle. So what can be the examples? This one. Okay, oxygen is in the group of 6A, so it usually has the oxidation number of 2 minus. So this means that you have the copper as +1. So you name it as copper. In parentheses, you put 1 here, not that 2 here. Just be careful. The oxidation number, not the number of atoms. And you end it with copper 1 oxide. So if I have this one. Now sulfur is in the group of 6A. So it also usually gets the oxidation number of 2 minus. So this copper 2 plus. So what can you say? In fact, in this case, you have copper with the oxidation number of 2 and it's end with sulfide here. And another example for polyatomic ion. Okay, this is this one. Now remember, when I talk about the polyatomic ions, I told you that not only you have to memorize the name of the ion, but also you have to know the charge of this sulfate here. So this has a charge of 2 minus, this has a charge of 2 plus. So you read it as copper 2 sulfate. So this is the idea of naming transition metals. You are going to write its oxidation number in the middle. Now you have some transition metals which have constant oxidation numbers. What were those? Those were silver and zinc here. So when I say this silver and chlorine compound, you're going to read it as silver chloride. So you're not going to put 1 here because it has a constant oxidation number, so this is not true. Or if I say this zinc chloride here, you're going to name it as zinc chloride and you're not going to put that 2 in the middle, so this is not true. So silver and zinc are the exception of the transition metals, but for the rest of the transition metals, you're going to write its oxidation number just in the middle. Now naming covalent molecules, really the easiest one, because you're going to use the prefixes for the numbers to indicate the number of atom, number of that non-metal in this compound. So what were those prefixes? You have mono here, D here, tri, tetra, penta, hexa, hepta. It goes like octa, nono, but you don't need those ones. Hepta will be sufficient, I think. So again, just start with the examples. You know this one very well. This is carbon dioxide. Now be careful, the first atom, the number of first atom is 1 here. You have only 1 carbon, so you do not call as monocarbon dioxide. For the first atom, the mono prefix is not used. Second one, this one. In this case, the first atom has 2 of it, so you call it as dinitrogen monoxide. So for the second one, you use that prefix monoxide. What else? Let's look at this one. This is sulfur hexachloride. Okay, what else do I? Okay, so if we just summarize all that we have done so far, how are you going to understand that? How are you going to name that ionic compound? Okay, rules. First rule. First, decide whether the compound is ionic or covalent. Now, if it's ionic, this means that you have the name of the metal plus the name of the non-metal and plus right here. If it does not contain a polyatomic ion, it can contain a polyatomic ion. In this case, you have the name of the metal plus name of the polyatomic ion. Now, as you know, you have a polyatomic ion which has a positive charge, the ammonium ion. So in this case, it can be just different. It can be name of this ammonium ion plus the non-metal elements plus you have the "ite" prefix, or it can be like you have the ammonium ion plus the polyatomic ion, name of the polyatomic ion, and you can just end your naming. So if it is just, it contains a transition metal, in this case you tell the name of the transition metal and you write its oxidation number in the middle. Then you have the name of the non-metal. And if the compound is covalent, it is the easiest one. You have the name of the non-metal, again a non-metal name of it, but in this case you're going to use that prefixes like mono, di, tri, etc. I made a mistake here. You cannot use mono for the first one. Let me erase this one. So it goes like tri, di, whatever it is. Again, the name of this non-metal containing its prefix mono, di, tri, tetrahexa, and you just finish your naming with "ite" here. I hope the examples and this summary will help you to understand the nomenclature of the compounds matter.